Hello children. In the last video, we have studied about the zeros of a polynomial and we already know about coefficients of a polynomial. Now we are going to study about the relationship between the zeros, that is the solutions, and the coefficients of a polynomial. Children, the zeros of the polynomial were those numbers which when substituted in the polynomials made the polynomials equal to 0. And we studied that 0 of a polynomial may or may not be equal to 0. So we are going to first of all find out the zeros and then we'll find out the relationship between the zeros and the coefficients. If you remember, we have studied about the method of finding the zeros of a linear polynomial. A linear polynomial is represented by ax plus b. For it to be equal to 0, x has to be equal to minus b upon a. So minus b upon a, that is, these are the coefficients only. So minus b upon a will be the 0 for a linear polynomial. Just substitute the values and get your answer. Now, today in this video, we are going to study about the relationship between the zeros of a quadratic polynomial and its coefficient. As we have already studied, quadratic polynomials have the standard form ax square plus bx plus c. You can see it on your screen. So, with this knowledge and the knowledge of splitting the middle term that you had in your 8th standard itself, we are going to find out the factors of our quadratic polynomial ax square plus bx plus c. This is how you will get the factors of the given polynomial. Here, in the first mathematical statement, you will see that it is written as some k, that is some constant. It may be 1 or any other number depending on the values which are given. The factors are x minus a, x minus alpha, x minus beta. Here, this alpha and beta are the zeros. And how do you get the zeros? You actually equate these brackets to be equal to 0. We'll be practicing all these things after few minutes. Beforehand, I'll just tell you a little bit about the relationship between the zeros and the coefficients. As I have told you just now, alpha and beta are the zeros. These are the representation. Alpha, beta, you have heard, they are the Greek letters. Here, alpha and beta are being considered as the zeros of the quadratic polynomial, and we all know that at the most a quadratic polynomial will have 2 zeros. That is why we have taken them to be alpha and beta. Now children, as per the relationship, the sum of these two zeros, that is alpha plus beta, is equal to minus b upon a. That's shown on the screen by the bold letters. And the product of the zeros, that is alpha and beta, alpha beta equal to c upon a, wherein a, b and c are the coefficients that you can check from the given polynomial itself. So these two are the relationship. We are going to prove these things later in the same video. Now, before moving to the next one, Let me tell you one more thing. Children, on the screen now you can see three relationships, that is alpha, beta and gamma. Now if you remember, we have studied that a cubic polynomial will have at the most 3 zeros. These are the relationship for those cubic polynomial. An example, that is example 5, is also solved here on the screen. But the most important thing is the last line of this page. It's clearly written not from the examination point of view. So children, this relationship between alpha, beta, gamma and the coefficients of a cubic polynomial is not in your portion of standard 10th. So ignore this part, this page, that is 32 of your textbook. You will only focus for quadratic polynomial in standard 10th. With this knowledge, let us move to the exercise. We'll directly begin with the exercise, that is exercise 2.2. Question number 1. I read the question. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. It is quite simple. You have to initially find the zeros of the quadratic polynomial, and then we have just read about the relationship. We are going to verify it. The first example, x square minus 2x minus 8. I will be explaining that, and the rest obviously you have to solve it on your own. Let's move to the next slide. It shows you the first question. Same question is typed. Now P of x, that is the polynomial of x that is given here, is x square minus 2x minus 8. If you remember the method of splitting the middle term, we are going to use it here and get the two factors. We are going to get the two factors. Here the middle term, that is minus 2, is split up as minus 4 plus 2. You know these methods, and we come up to the two factors of the given polynomial as x plus 2, x minus 4. Now children, this p of x, that is our given polynomial, if it has to become 0, then either of these two brackets must be 0. Either x plus 2 will be equal to 0 or x minus 4 equal to 0. If one of the bracket becomes 0, then the entire polynomial will become 0. So, we are equating x plus 2 equal to 0 as well as x minus 4 equal to 0. If I equate this, I get x equal to minus 2 or x equal to 4. Now children, you can substitute these in the given polynomial, and you can check. You will see that the entire polynomial becomes 0. You can do it yourself mathematically. This means that x equal to minus 2 and x equal to 4 are the two zeros of the given polynomial, and we have just now learned that we represent these two zeros as alpha and beta. So let me take alpha as minus 2 and beta as 4. It is your choice. You can swap those two also. This is how I get my alpha and beta, that are the two zeros of the given polynomial. And if I study the given polynomial, I will get my a, b and c. Down it is shown here. A is equal to 1. This is very simple. You have to just go on checking the given polynomial, comparing it with the standard form. So a is 1, b is minus 2 and c is minus 8. That is the constant term over there. With this knowledge, let me move to the next part. The sum of the zeros, that is alpha plus beta. Here alpha is -2 and beta is 4. So, I have substituted it over there, and when I solve it, it is equal to 2. Similarly, if I find alpha beta, that is the product of the two zeros, it is -2 into 4, which is equal to -8. Now, I have to write this in the form, I have to relate it to the coefficients. So, look at the first part, that is alpha plus beta, we got it as 2. If I try to write this 2 in terms of the coefficient, children, I can write it easily as minus of -2 upon 1. Mathematically it is correct, minus minus becomes plus, 2 upon 1 is 2. So, I have just rearranged 2 as minus of -2 upon 1, and alpha beta, which was equal to -8, I have just rearranged it as -8 upon 1. This is rearrangement only. You will slowly come to know why we rearrange. Now, if you look at these two values which we have generated just now, that is minus of -2 upon 1 and -8 upon 1, you will see that the denominators are same. That is nothing but equal to our A. What is our A? It is already found to be 1, and it is there in our these two relationship also. Now, look at the numerator part of alpha plus beta, that is minus of -2, RB is -2. So, the numerator becomes minus B. I have just substituted it as minus of B upon A, and this proves the first relationship, that is alpha plus beta equal to minus B upon A. The second one, it is -8 upon 1. We have just now studied that the denominator is A, which is equal to 1. Whereas, if you look at the numerator, it is -8, which is nothing but R C. So, we get alpha beta equal to C upon A. This proves the relationship between the zeros and the coefficients of a quadratic polynomial. And this is true for each and every quadratic polynomial. This first one is solved for you. You have to solve the next 5 sub questions that is now on your screen. The method remains the same. Try it yourself. Now, I read the question 2. It is, find a quadratic polynomial each which with the given numbers as the sum and product of its zeros respectively. Let me compare this question with the question 1. In question 1, the polynomial was given and you found out the zeros as well as the relationship between zeros and coefficient. Now, in question 2, the sum and product of the zeros is given and you are supposed to find out the quadratic polynomial. So, similar, I mean they'll have the exact opposite steps. Let me solve the first one and explain it to you. Here, the very first sub question, it is 1 by 4, which is nothing but equal to the sum. That means my alpha plus beta is 1 upon 4. And the product of its zeros, that is alpha beta, is -1. With this, I explain the first sub question. Obviously, the next 5 you will be doing it on your own. Now, the next question, that is question 2, is flashed on your screen. As I have told you, look at the first statement of the solution. Sum of the zeros equal to Alpha plus beta, that is 1 by 4, that is given in the question, and we all know that it is equal to minus b upon a. We have proved this relationship just now. Moreover, the product of the zeros alpha beta is equal to minus 1, and it is equal to c upon a, that we all know. In between certain steps, numbers are inserted. Let me tell you why. Minus 1, alpha beta equal to minus 1. I can write minus 1 as minus 1 upon 1. Mathematically it is correct. Now children, if you look at the sum of the zeros and you study that statement, it is 1 by 4 which is equal to minus b upon a. If you look at it, a will be equal to 4. I'll equate the denominators. That is how I am getting a as 4. So in the second statement also I should have the denominator as 4. Then only I'll be saying that a is actually equal to 4. So what I am going to do is I am going to write minus 1 upon 1 as minus 4 upon 4. Again it is mathematically correct. My aim was having a equal in both the statement. That is how you have to make the changes. Now look at the two statements properly. Our a comes out to be 4. That is written in the next statement. So a equal to 4. My b will be equal to minus 1. See it properly. Minus b equal to 1. So b will be equal to minus 1. And c is directly equal to minus 4. What you have actually done is you have to just check the or equate the denominator to the denominator, numerator to the numerator, but you have to check or concentrate on the sign of the coefficients also. It is equally important. Now with the knowledge of a, b and c, I have already got a equal to 4, b equal to minus 1 and c equal to minus 4. I will put all these values in the standard form, that is ax square plus bx plus c, and I will get the quadratic polynomial as 4x square minus x minus 4. This is how I have obtained the quadratic polynomial. The steps are very easy to understand. Okay children? So, your job is now to solve this entire exercise and understand the relationship between the zeros and the coefficients of a quadratic polynomial. Thank you for now.